and I just want to go over some of the tools that we use here when we rebuild these 60 pumps. Let's start with this one so I can use it to point. Just a simple magnetic pickup tool. We use this to remove the pilot check piston on the valve blocks of these units. So we'll use this as a pointer, and we'll go over the basic tools that we have here. Complete set of wrenches. We start with 3/8, 7/16, 1/2 inch, 9/16, 5/8, 11/16, 3/4, 13/16, 7/8, and 15/16. None of these are a high-end tool. These are all cheapies. I won't mention any names. You may be able to see some of them. Some of them are good tools. Most of them are just, bought them off the back of a truck or at a tool sale at a local swap meet or whatever. They don't need to be the top of the line. Here we have a 1.25 inch socket, deep, a 7/8 deep socket, and let's take down this tool. This is a motor cap. This is a motor cap tool for the E47 units. We won't be using this today because we're rebuilding an E60. But this is a tool that the directions are actually in the back of the shop manual for the E47. You can make your own. Well, we decided to make it out of aluminum because it's a softer material than steel, and we felt we'd be better off having this part here contact the brushes being made out of aluminum instead of steel. Here we have a pressure gauge, 5,000 psi. This one happens to be liquid filled. You don't need a liquid filled one. We use this to check pump output pressure. Sometimes we do it right here in the vise. We usually do it on the stand, but sometimes there's a pump that comes in that's questionable, and we don't want to contaminate our stand with the mix of oil and water and debris that are inside most of these units, which you'll see shortly when we open up this E60, because very rarely do they come in clean. All right, now let's pan down a little bit further on the tool board here, and we'll go over a couple other tools that we often use. They call this one a hose hook. That's for removing radiator hoses. We also have our larger wrenches here, 1.16 inch, which we don't use in the rebuilds. 1.25 inch. This is the wrench that we're going to use to remove the B and C valves on this E60. Sorry I jumped back on you. 1/4 inch T-handle Allen key. It's good for starting the bolts, but very rarely will you be able to get out some of these bolts that hold the angle blocks on. That's what we're using the Allen for. We have a scraper, nothing fancy, just a putty knife, spackle knife, whatever you want to call it. It's pretty thin. It's not a chisel type scraper. And we have a round file, which we usually don't use. And we have a triangular file. And we have a aluminum pipe wrench that we definitely will be using. So let's get the E60 up into the vise here, and we'll get started. So I'm going to go get it, and we'll be right back. Okay, tonight we're going to be rebuilding this Meyer E47 hydraulic unit. This was a trade-in. I don't know the history of it. I'll show you later on in this video that there's some severe corrosion and delamination right here in the billet PA block. I'm not sure if it's going to affect operation or not. We may find out later on that it will. I do have some spares that we can interchange and get this pump working again. If I had to guess, I'd say this is an early 80s unit. We'll find out the exact year once we open it up. But based on the serial number, I'm reasonably sure it's 84, 83, somewhere around there, 1983, 1984. Just at first glance, the stud's broken off the motor, which we be replacing anyway, because when we rebuild a unit, we don't send it back out with the original motor or used motor. We always put a brand new motor on a unit before we sell it. So that's not really important to us. It would be important to you. In this case, if it was a rebuild for a customer and the internals of the motor were in good condition, we actually sell a cap and brush kit that has a new stud on it. And it's just take this cap off, put the new cap on, and you're back in business, provided the rest of the motor's in operating condition. So the first thing that we're going to do is we're going to make sure there's no burrs around the hole where the bolt goes through the lift ram to the lift arm. And we want this to be nice and smooth, no rust, no paint. Clean it off so that when we remove the top cap, it slides right up and off the top here. In the past videos, I've used a scuff pad, a file, because I'm trying to make it more like what you may have at your disposal at home. But in the interest of time, the last video that I did ended up taking like 9 hours. And I just can't have one be that long because, well, you could figure it out. So what we're going to use is we actually have a 3M abrasive disc on an angle grinder, an air-powered angle grinder. This is a medium grit, and we're going to use this to remove any burrs and any rust or paint that's left around the top of this angle ram. We only have to go down, you know, to where it, depending on what your unit looks like, it may be painted. We only have to go down to where the paint stops, because we don't need to do anything with the part that's normally inside the unit. That's usually clean. And this one here is actually very clean, and we really just want to make sure that there's no burr that's going to catch on here on the top of the hole or the bottom of the hole. So that when we actually assemble it and we put the new cap, on with the new wiper seal in it, we don't want it to get caught on this lip if there's a lip. So we're going to take that off using the abrasive disc and air. So bear with me on the noise, and I just want to say that I'm wearing safety goggles. I don't want to hurt myself in the process. So here we go. And to make it easier while you're doing this, you could just use a screwdriver, slip it through the bolt hole, and you could twist the ram to gain access to the other side. So you don't have to actually walk around the unit while you're working on it. This is just a little bit of grease on here. It looks like rust. I'm actually surprised that this is in as good a shape as that it's in, this part that protrudes outside the unit, because when I removed the lift arm, which was still attached to this unit, that's the way it was given to us, I actually had to drive the bolt out with a hammer. It was rusted in there pretty good, which is why I'm surprised. So, we got that done. Put our blower back on because we'll use this quite a bit throughout the rebuild process. And the next step is going to be to drain the fluid out of the unit. And we start by removing the vent fill plug and go from there. So I have an old pot that I got from my wife. We're going to drain our fluid into here. This is an E47 unit. You're only going to get a little less than a quart out of it, even if it's filled right to the top. So we tilt the pump so that the oil will drain into the pan. I'm going to switch gloves because when I work on the hydraulic part of the unit, I wear nitrile gloves. It's not that I don't want to get oily, it's that when you get oily 15 times a day and you have to wash your hands 30 times a day, your hands get to be in pretty bad shape. So it's also much easier for me to wear the gloves, and if the phone rings and I have to grab the phone, it's easier for me. I just pull the glove off, answer the phone, and then I come back to work by putting on another glove and resume where I left off. So got our nitrile gloves now. Some of these, the older ones, it's a 9/16 I believe, to remove this bushing, because there's a reducer bushing and then the vent is threaded into the reducer bushing. But on this one and the current production, the hex portion of the bushing is 5/8. problem is it's so close to the cap, you can't really get in there with a wrench or a socket unless possibly you can get in there with a thin wall. But what we do is we just take a, not made in the USA wrench, a cheapo, and we grind down a portion of it so that the wall is very thin and it fits on there quite nicely. I've also learned over the years not to beat the heck out of my hands by hitting on the wrenches. So instead we use either a rubber mallet or a hammer. I have a feeling I'm going to be a little bit surprised with the condition of the inside of this unit, because I already removed the crossover relief valve for another video, and I actually found Meyer M1 oil inside the unit, which was a surprise to me. So usually we find soupy, gunky, all colors of the rainbow and lots of water. So this one's actually going to surprise me, I think. We'll know in a minute. So now that we have our vent removed, it's going to allow the oil to drain out of the reservoir much quicker. And actually, we got some leakage now out of the crossover relief valve. So that must have been some kind of pressure here holding fluid in the hoses. I just have a can where we throw all our parts. And we can address where they go later on as we clean them up and be reinstalled. Our drain plugs are 11/16. And once again, I don't like to beat up my hands, so I'm going to use a wrench. These plugs are kind of rusty, as you can see. Make sure I got the wrench firmly on there. Now, these plugs shouldn't be tight. Like the sticker on the front says, 6 to 7 foot-pounds or 75 to 85 inch-pounds maximum torque, because the threads don't make the seal, the O-ring does. And at that torque rating, the O-ring is crushed sufficiently to make a seal. So I'm just going to try here, give it a little tap. Okay, it's going to come loose nicely. We work it back and forth to break the O-ring free. And, we'll do this most of the way out. And after I get a couple of turns on it and it's separated away from the sump casting, I like to give it a little shot of brake cleaner. The brake cleaner we use is 100% acetone. I don't use anything with any kind of trichloroethylenes or anything nasty in it. A lot of brake cleaners on the market have toluene, benzene. Definitely not things you really want to use. So we just use a little acetone brake cleaner. You find it evaporates very quickly, leaves no residue, and it's not harmful as briefly as it's in contact with the seals where it's going to do any damage to them. So here we go. Okay, O-ring broke free. We're ready to remove it. I'm going to tilt this forward a little more because I'm going to get a pretty good gush of oil out of this thing with the vent removed from the top. What you can do is you can actually put the vent back in, just a couple of turns, and it'll slow down the flow when you remove the drain plug. And we'll try that. So there we go. See, the reason I remove the vent is because it glugs if you don't take it out all the way. So by slowly backing this thing out, I'm going to allow the oil to flow out of here more steadily. And this is the part that's interesting. This is where you start to see the globs of junk that are in the oil come out. So let's see what we got. So far so good, no signs of water. I'm very impressed. I have a feeling that this particular unit may just need a new PA block because of the delamination. And even at that, if it doesn't affect operation, what I may end up doing is rebuilding it and saving it for a loaner pump that I could loan out to my customers during a storm while we make repairs on their unit. I don't think anybody around here does that. It's something we already offer. We have an E60 that's available as a loaner to our customers. Now you can see that this drain plug has quite a bit of junk packed in the hollow. I'll grab a pick here and see if I can show you the gunk in here. You can see it's kind of slimy and here we go. So usually your debris will accumulate in these hollows because you have a hollow in this one and you have a hollow in both of your filter plugs as well. So I try to clean most of the parts as I put them in the can, so that this way the can is not full of junk and debris. So we try to give these a little cleaning before we throw them in the can. It's just less cleaning we have to perform before we reassemble. The filter plugs I'm going to leave for now. What I'm going to do is I'm going to loosen this in the vise and tilt it a lot further so I get more of the oil that's laying in the base out. Alright, we'll stand it back up. Now it shouldn't drip while I perform the next steps. Next we're going to remove the top cap, but I think I'll remove the motor because it'll give you a better view of what I'm doing when I start to remove the center section of this unit. Older units, these are 3/8 heads on these bolts. Newer units or aftermarket motors will have 10mm bolts. I'm pretty sure these are going to be 3/8. And yes, they are. Now, these can be a real bear because the threads are down here in the aluminum. These are very long bolts, and a lot of times they'll corrode in place down here. And they may snap off, which it's not a real reason for an alarm if you're willing to go this far. Getting them out and going the distance, so to speak, shouldn't be that difficult for you. But it's all according to your skill level. We'll cross that bridge when we come to it. So let's begin by trying to remove these bolts. All right. You kind of know right away if they're going to come out or not because it doesn't take much. They're only grade 2s. They're not hardened bolts, so it's pretty easy to snap them if they're seized in the thread portion. I really got myself wondering where this one came from because it doesn't seem to be in as bad a shape as first look. As you go back and forth a little bit, got to clean some of the corrosion out of the threads. They're dissimilar metals. You have a steel bolt threaded into a cast aluminum housing, and you get quite a bit of white corrosion. These have actually come out before taking the threads with them out of the aluminum housing. Not all the time, not common, but it's happened before. So one good thing, which I'll show you in a moment with the E47 unit, is there's 2 sets of holes you could use by turning the motor just slightly. You could use either set of holes. So one set's supposed to be for the Prestolite motor, and one set's supposed to be for the American Bosch, which is what this is, the American Bosch design. And we found that you could use either set of holes with the American Bosch. Some of the aftermarket motors don't fit so well. You have to ream the holes where the bolts pass through the base plate of the motor to be able to catch the second set of holes, but it's not a big deal. Usually these come out a lot easier. Oh, what do we got here? Five-sixteenths. Okay, back to the 3/8. I usually have that 1/4-inch ratchet ready to go here, but evidently it was being used for a different task in the vise, and there's a 5/16 on it. So, okay. So these are free. And we'll remove our motor. Sometimes just got to rock it a little bit. It seems like this one's actually loose here, but the base plate of the motor itself is getting caught on the aluminum housing. Our bolts are free. It's clearly not the bolts that are holding it. Well, we could also remove it this way and show you. What the inside of the motor looks like. There's a small washer on here. It's probably stuck in place. Quite a bit of grease on here. Somebody either overdid it or the pump shaft seal is leaking. You can see what's left of the paper gasket that goes in between the base of the motor and the base plate of the motor. We'll just tear that out of the way. This is not a common occurrence, having this fused together here. Let's just see if we can persuade it to come loose. Use a chisel. And I'm actually going to move away because here, right in the front, it's tempting to hit it here, but this is where the threads are in the housing, so I'm going to move out to the outside a little bit. There we go, wasn't that bad. Okay. This piece, the base plate of the motor, has a bronze bushing in the center of it, and the shaft of the motor is a polished steel, and you can see this one's actually rusty, but the polished shaft rides on the brass bronze bushing, and that keeps it lubricated because the bronze actually absorbs the oil. So I'm going to try to clean the shaft up a little bit to show you what we got. And even with all that oil on there, you could see that it rusted up quite a bit, and it's not as highly polished like it should be. So that'll create extra drag, and which will increase the amp draw of the motor. It's not unusual to find like cigars or paper in here. There's some type of an insect that seems to put cocoons inside of these units. They really like to do it. There's a weep hole in the front of this unit, which allows water to drain if it was to get in there, and oil. If the pump shaft seal is leaking, it'll weep oil out of these holes. So if you have oil dripping out of this hole, or it's always wet around this hole, you know that your pump shaft seal is leaking. It's not uncommon for that paper cocoon to plug the holes at times, and I believe this back hole has a bit of debris plugging it. Okay, so for a few reasons, we used to tear these apart and we degrease them as we went. What I find myself doing now is actually just putting it in the slop sink and soaking it down with well, a particular brand of dish detergent that they use to wash the ducts after the Valdez oil spill. I'll leave it at that. And that particular brand of dish soap does a wonderful job on degreasing the pump. Everything goes down the drain. I'm not spraying 3 cans of solvent and polluting the air. And the solvent, the dish detergent is actually going into a facility at wastewater treatment, and everybody's happy. So I'd rather do it that way. It's also easier for us. So before I put this in the vise, I washed it in the sink. So that's why we have some moisture in here. It makes it difficult to tell if the pump shaft seal is leaking. Regardless, we always change the seal for the pump shaft when we rebuild the unit. So, all right, now that we have the motor out of the way, we're going to remove the top, and then we're going to remove the tank, and we'll see what we have inside of this unit, and we'll find out what model year it is also. So I'm not as prepared as I should be for this. I usually have my sockets ready to go. However, somebody else is working in this area, and things aren't all where they should be. So. We've had conversations about things not being put back where they belong and the way they belong, but we'll just leave it at that. I should have had this off already. So. Right, well, these are 1/2-inch nuts. They also could be removed with a wrench. There's enough room. They're nylock nuts, and they actually have a nylite washer underneath them that crushes and makes a seal when the unit is assembled. They're not reusable. They're a one-time use washer. Quite often we have pumps come in and they're missing the nylite washers, and we know somebody was inside the unit. And by assembling it without them, quite a bit of water will get in around these nuts, believe it or not. So it's always a good idea to replace the nylite washer when you have the unit apart. We actually replace these nylock stop nuts too. We don't reuse them. You could reuse them, but I'd rather not. That way I know when I torque them to spec, they're going to stay there. There's no memory in the nylon from the previous torque. And for the price of them, it's well worth the peace of mind, knowing that you put it back together right, and it's going to stay that way. So let's get these off of here. And in case you're wondering, it's actually 12:30 in the morning right now, which may be the same situation you're in when you're doing this work. During the day, I just don't have the time, and there's way too many noises and interruptions. Normally I'd be standing here doing this now with the radio blasting. I'd have the exhaust fan on. I even went and shut the compressor off so it won't kick on when I blow off parts, just to keep the noise level down. And I'll try to be quick whenever I use power tools or air tools. And I'll try to be a bit more brief and to the point with this video. So we have our 3 nuts off now that we're holding the top cap on. Now we need to remove the nylite washers. This one was crushed to the point that it popped right off. We want to try to remove the remnants because these actually will wedge the top on, and that's actually what they're meant to do. is make a seal by getting pressed down into the slight cavity that's left around the stud protruding through the top cap. So you can see one of the nylite washers here. I'll show you what they look like when they're new. One more. These aren't actually coming out whole. The pieces are still left where they're wedged in between the stud thread portion and the top cap. So we got it that far. Now we're going to use a hammer and a screwdriver. Yeah, it seems primitive, but it works. I don't really know a better way. So we're going to use a hammer and a screwdriver, and we're slowly going to work our way around, removing this cap evenly. We don't want to drive it all the way up on one side. We want to work our way around and lift it off uniformly. So there's a little lip here. You can get your screwdriver caught on that. I like to start out with a smaller screwdriver. Work our way around at the studs. It's usually a good place to start, but you got to feel your lip with the screwdriver, and you want to make sure you have a good bite before you start tapping with the screwdriver. Another thing I like to do is my drain pan has the oil in it. And when I'm doing something like this, I move it out of the way because it wouldn't be the first time that it got spilled. So we'll just move that out of the way for now. And we'll start working our way around here, removing this top cap. See, it's starting to lift already. Way around the back. A piece of nylite washer just shot off of that stud. Now, we got it free. You can see the O-ring that actually seals the cap to the inner surface of the tank. Here's the O-ring. We're not going to reuse it, obviously. You can pull it off now if you want. I'll do it just to show you. And I like to take a little brake cleaner and just spray that shaft a little bit. It wets it a little to make it easier to remove the top cap. This cap's coming right off very nicely. Okay, inside the top cap, I actually have pictures of this up on smithbrothersservices.com website. Here on the outside we have a wiper seal. Its job is to wipe any debris that's on the shaft off the shaft before it goes down into the unit. On the inside is a millable gum O-ring that actually makes the seal. And there it is. It's usually clear or white. Plastic, well, it's actually millable gum, and that's what makes your seal. So, and then here we have the guide bushing. This is a nylon guide bushing. Its job is to hold the shaft centered as it goes up and down, so it doesn't wear into the aluminum housing. It rides on the nylon. Get this thing cleaned off before we put it to the side. All right. And now, just to show you what's going on here, I'm going to remove the tank. Normally I would remove the cylinder, but in this instance I'm going to remove the tank first. I can put my drain plug back in here finger tight, because it's possible there'll be a little gush of fluid, maybe a few ounces that are on top of the lift piston, which you'll see in a moment. But I don't want it to leak out being that I removed the drain pan. So now we grab our rubber mallet, give a couple of taps, work our way around, loosen this up. You can see it starting to separate here on the bottom. What I've also found is you can take a screwdriver, and this is a good spot right here. This is a smaller screwdriver. I want to use a little bit larger one. And pry upward, put some pressure on it. You see it moving with the screwdriver. Well, when I put pressure on here, if I smack it here, it's going to work its way up. You can see it coming up. And it's pretty much off now. There's more corrosion down here than I expected, judging from the rest of this unit, but well, it's not that surprising. trying to do this carefully so that I can show you what it looks like without the tank on it. Trying to leave the cylinder in place. There we go. Okay. The older units had the serial number on the decal, and the newer ones have it stamped in the base, where the bottom bolt goes through the bottom of the unit, bottom mounting bolt, and the newest ones have no serial number on them whatsoever. So, inside of this tank isn't too bad. You can see the rust line where this pump was leaning back at some point, and it had some moisture in it, and it created the rust line in the pattern that you can see inside. Quite a bit of gunk around the bottom here. You can see the rust on the cylinder. Here we have our grooves down washer. It's called the grooves down washer because it has 4 grooves in it. 1, 2, 3, 4, and the grooves face down. It used to be referred to as the grooves down washer, and Meyer started calling it the groove washer. I like to always refer to it as the grooves down washer because then you never mess up and forget which way it goes. The reason it has grooves in it is so that any oil that gets trapped on top of the cylinder, on the top, above the ram in the cylinder, as the ram comes up, that fluid needs to go somewhere. So as the fluid's coming up and getting compressed, it squirts out of these holes back into the reservoir. So that's the purpose of the groove washer. All right, this one's pretty rusty. We'll polish it up real nice before we reassemble the unit because you don't want it to be rusty. I'm just going to give it a little clean off here. Judging from how much rust you have inside your unit, you can tell just how bad it was neglected and for how long. The longer you neglect it, the more damage you're going to find and the more it's going to cost you to rebuild. All right, this one's, let's just blow it off a little. It's not really bad, but it does have quite a bit of rust on it. So we can reuse it. It's not a big deal. We'll polish it right off with that same abrasive disc on the angle grinder. Our casting date is inside the base. It's cast right into the sump base. We'll check that out later on, but for now, I'm going to remove the cylinder. Just got to get my drain pan back. It's going to get a little messy here. All right. Now, one of the things that'll make this easy to remove, there's going to be some suction here. If I was to remove this filter, it would come loose easier, but I'm just going to give it a little wiggle. And I can see actually right now, this cylinder's full. There's oil right up to here, inside the cylinder. So I'm just going to rock it a little bit, see if I can get it loose. Gives me a hard time like it is, slightly. I'll grab my 11/16 wrench. Take out this filter plug here. This is going to release any oil that's under the cylinder, where it sits in the base. A little shot of brake cleaner on there. We talked about to lubricate the O-ring and help it break free. Back and forth to help it break free. Move with my fingers. I'm going to tilt the base slightly forward to help with drainage. And we'll remove this plug, and there's going to be a filter inside. Okay. Grab my needle nose pliers. You can see that this, in comparison, the inside of this one's actually quite clean. Okay. Needle nose pliers, here's our filter. Pluck that out. Looks pretty clean. I'm impressed. Okay, you can reuse it, a little solvent, blow it dry with compressed air gently, and you can reuse it. See the fluid squirt out of there when I rock it? See it? Because it's breaking the seal below the cylinder. There we go, broke free. Okay. Now I can carefully hold this and pour the oil out that's above it. put this to the side. And I'm going to turn this up so you could actually see. First I'm going to grab a rag. I'm going to turn this up so you could actually see the globs of debris and gunk inside this unit. Although the fluid was clean, it's very clean fluid, means very little. There you go. Just globs. Look at it. Alright. So now what we do is we turn it this way in the vise and tilt it down again so that all that crap, for lack of a better word, can drain out. And just to help it along, we'll use a little brake cleaner. Now what you can't see is that down inside the base portion, underneath the cylinder, there's a lot of debris coming out of there too. And when you change your fluid annually, that's not a place that you're draining any debris from. The only way to get to that is to do this, disassemble the unit. So I recommend to my customers, every 5 years, and that's with annual fluid changes, every 5 years, have your unit rebuilt. Because having it rebuilt allows you to get all this debris out of there. Alright. We can go over some other parts now, while we have this in this condition. Okay. I don't know how much of that cavity you can see, but the debris that I was talking about below the cylinder was down inside of here. This is the cylinder base O-ring. It seals the base of the cylinder to the sump base. We're going to remove that. There it is. This is the plastic baffle here. Here's the filter on the intake side of the pump. Believe it or not, we take these out and we throw them away. We've been doing it that way from day one. Something that we were told to do in Meyer service school, because having that filter plug up on the suction side is far worse than anything that this pump is going to suck in during operation, because there's nothing in the oil that can harm the gears of the pump as long as you service it. The only thing that could possibly damage the gears or hurt the gears would be rust. And as long as you're getting the water out and not allowing water to accumulate and not allowing rust to occur, then rust should not be an issue for you. What I'm doing now is draining the actual pump itself. When I remove that screen, it allows the oil to drain back out of the pump itself. I'm not going to get it all out, but I'm going to get the majority of it out. So it's just less to spill on the floor when I take out these 3 studs momentarily. Okay, now I'm going to remove these 3 studs. All 3 of these studs have remnants of the nylite washers underneath them. We'll clean that off with a piece of scuff pad. Needle nose plier, but for now I'm just going to remove them. Normally remove them with a small pipe wrench that is not hanging. Oh, there it is. Right where it's supposed to be. Okay. So these shouldn't be that tight. Should be easy to remove. Submerged in oil inside the tank, so corrosion on the thread should not be an issue. You can see these 2 have a retainer on them that hold the plastic baffle down. The reason for the plastic baffle is there's a return port right underneath it, and when the oil returns to the sump, to the tank, without the baffle, the oil can squirt up and hit the inside of the cap, and it may create foaming. This way here, it keeps it near the bottom. So that's why that's that way. Okay. Cleaning off my studs. Shop cat's getting into something he shouldn't get into. All right, get this one off. Plastic baffle. It's funny, you know, this one here is nice and white. Quite often these units will come in and you'll find that the baffle's pink. Pink as pink can be. Pepto-Bismol pink. And that's from using automatic transmission fluid inside the unit instead of Meyer M1 fluid or similar product. Okay. Get this one off. Excuse me. All right. And there's another O-ring here that seals the base of the bottom part of the tank where it slips over the sump base. We'll just remove that O-ring as well. Toss it. All right. We're going to remove the pump shaft seal. We do that with a seal puller. Nothing fancy. Just a standard seal puller, nothing special. We use the smaller part to pluck the seal. It's easier to do while it's still bolted to the sump base and in the vise, so we do it now ahead of time. And we're just going to drive this in to the seal and pluck it out, being careful not to gouge the bore. Usually just a few taps in there, just enough to make sure you got it in there good. And then just a quick pluck, and out she comes. And again, this is another good time to move that oil pan out of the way, because you can end up with a nice bath. So make sure we got it tight in the vise. All right, get that in there. A couple of more taps just to get it positioned again, and then just one quick motion, out she comes. There it is. And you can see the blue around the edge, that's like a silicone sealer that seals the pump shaft when you drive it into the bore. Some of them don't have that on there. You can see here's a new one. Ours are green, so we don't have to apply silicone. Some of the aftermarket ones may not have anything on them. In that case, you would apply a thin bead of silicone around the edges of the seal before you drive it in. Now I'm just going to tip this up and show you what it looks like with the seal removed. Okay? And then you could also actually see the two sets of holes I mentioned earlier in the pump itself. Here's one set of holes that we were using, and here's one set that we're not using with a little bit of debris in. We'll chase both sets of holes with a tap and apply Never Seize or an anti-seize compound. I refer to all of them as Never Seize to both of these sets of holes, so that even if we're only using the one set for now, the other two are coated and protected so that they don't corrode for possible future use. So, all right. Now, we're going to remove these three nuts. Studs may unscrew with them, but we're going to remove these three nuts and take our pump off. Somebody's going to have a bit of a talking to in the morning, because I shouldn't have to hunt for my tools the way I'm having to hunt for them right now. Especially something as common as that 1/2-inch socket. So, a little bit of oil on here. Clean that up. Okay. Suppose I go back to the 1/2-inch wrench now, but I'd rather be using the socket. Things go a little smoother. You do it with the wrench. These are only torqued to 125 inch-pounds, so they're not very tight. often there's corrosion in the bore. Again, dissimilar metals. You got steel studs going through an aluminum passageway, you're going to get corrosion. So even though these are unscrewing, you still may have to help this pump off of the studs. Which is why sometimes it's actually easier if the studs just unscrew. You don't have to fight with it as much to get it off, but we'll see. Again, these are nylock nuts, the same thread pattern that's used on the top cap, and we don't reuse these. We install new. Brake clean on there may help. Alright. One more to go down here on the bottom. Rusty. All that noise you hear is the cats. Got a few kittens here right now. All right, that's our third nut. So we should be able to remove the pump. I always try to start out with the rubber so I don't damage anything. Just give it a few smacks and see where it goes. And like I was talking about, corrosion, it appears that may be the case with this one. So again, we're going to use a screwdriver, except this time we're going to put it down in the cavity here because we don't want to damage anything. We're just going to see if it's working it that way. It wants to come loose. Quite a bit of slop and gunk in here, but you can see it's starting to separate. It appears it's the two back ones, or one of the back ones it's holding. As you can see, I'm wiggling it. It's more in the back that we're having a problem. Let's see if I can switch hammers. Like I said, I like to start out with rubber, but sometimes there's no substitute for good shot, and you can see the powder falling out onto the vise here. It's the corrosion you get. Alright, see all this powder fell out of here? Okay. Here's our pump. We can drain it now. Without the shaft seal in there, it'll drain completely. So don't tip it until you're ready to drain it. When you do, it'll drain quickly. Okay. Got a pump off now. These studs we clean up. It's easier to do it while they're threaded in. Now, if this is a newer unit that hasn't been assembled for so many years, there's a pump check valve here that will come shooting out, spring loaded. But being that this has been assembled for so long, we're going to have to persuade it to come out. So I have to use a pick, and I'm going to press on the O-ring and try to dislodge the O-ring, because that's what's holding the check valve in right now, the O-ring. So you just got to catch the O-ring, and once you work the O-ring out, see the O-ring, then the pump check valve should come out. Sometimes they don't. Sometimes you got to help them along a little bit. Of course, this is going to be one of those. Normally, I'd turn to grab a tool and the thing would hit me in the chest. There's a spring and a ball that you'll never see again. At least you won't see the ball. What we find when they're stubborn like this, the easiest thing to do is use an easy out and just begin to thread it in. Usually once you give it just a slight turn, that's enough to dislodge it and have it come free. However, just my luck, easy out's not where it should be. It's my fault for not preparing before I began this rebuild. So, there's going to be a break here and then it's going to restart. Alright, found my easy out. A pair of locking pliers here. So I can use it to turn the easy out. There's a ball and a spring behind us. The ball is pressed up against the back of this right now. So what I need to do is just catch this. You hear the ball? So I need to just press in, just give a little tap, and twist as I'm tapping, get it to grab a little bit. And then I should be able to put my locking pliers on here. And give a turn, and she should come right out. I heard the ball shoot out. I got lucky that time. It landed on the bench. Here's what the seat looks like. And here's the ball. And then if I grab my pick, I can show you what the spring looks like. Nothing fancy. Spring, seat, ball. If to decide, I'll remove the seat from the easy out at a later time. In the interest of time, you don't need to see how I do that. It's pretty simple. 2 pairs of pliers, off it comes. So, as far as cleaning these up, we just use a abrasive pad. It's like shining a pair of shoes. We find this way works best. Like I say, it's easier to do them while they're snugly threaded into the sump base. If they're really bad, we can remove them and clean them with a wire wheel on a grinder. This one here is pretty bad. I may actually do that later, but for now I'm just going to clean off what I can while we're in the messy stage right now. These are fine thread studs on this end, and coarse on this end. You want to be real careful if you're going to use a wire wheel on a grinder or a drill. It's pretty easy to wipe out these threads, so you don't want to get too carried away using power tools. Alright, so sometimes we remove these. It's not imperative that you do. Sometimes I say we should because it'll make it easier for the next guy to get them out. But other than changing the actual base itself, there's no real reason to remove them. So we'll just leave well enough alone for now. Take our drain plug back out. What I did not remove in the front here was the high pressure filter. The fluid leaves the pump, travels through the unit, it passes through this port on its way to the valve block. And it's the high pressure port, so spec is 1650 psi passing through this filter on its way to wherever it's going to go. So all the fluid, once it passes through the pump, is filtered before it goes into the rest of the system. And again, it's an 11/16. I like to save my hand. Put our 11/16 wrench on there. Tap, tap, tap with the mallet. Back back and forth to free up the O-ring. A little shot of brake cleaner to help. Back and forth, back and forth. You can tell when you can move it easily with your fingers, it's free. Drain pan. There's not going to be much oil in here, but I don't want it to go on the bench. So I'm ready to catch it. Tilt it a little bit. Remove our plug. Nice and clean inside, very good. Grab needle nose pliers. Pluck the filter. Now this filter you want to examine. Make sure that there's no signs of steel shavings on it, because that would indicate pump wear. So this has some slime on it. I don't know if you can see that. It's actually quite clingy. A couple of metal shavings, nothing major. Again, we can just clean that with a little bit of solvent and blow it out with some compressed air. Again, I'm going to move our drain pan out of the way because I don't want to have a bath. And now we're going to move on to removing the coils. We sell a ton of valves. One of the reasons is that the stud is part of the valve. So if when you go to remove these nuts, you snap off the stud, you're buying a valve. There's no fix. Some guys say, well, you could TIG weld it, you could do this, you could do that. But by the time you add up, unless you could do it yourself, as far as TIG welding, you're into it for quite a bit. Having somebody else do it when you should just replace the valve, because God only knows how long it's been in there to begin with. Just clean it off the part of the sump casting where the cast date is, and it's 1984. So I was pretty close in my guesstimation when we started this. These are 7/16, they're quarter 20 threads, they're 7/16 nuts. Very carefully turn these very slowly and watch the stud. If you see the stud moving at all with the nut, stop. Okay, I got lucky. I'm going to do the same with this one. Okay, I got lucky again. One of the things we do is we replace these nuts with brass nuts so that they cannot rust in place. So we'll throw these steel nuts to the side. We don't need them. Had they been frozen, we don't mess around, even though there's a chance the valve itself may be bad. We use a nut splitter and crack these nuts off. Here's our nut splitter. I'll put the nut back on and show you how we would do it. The nut splitter presses against the flat of the nut, has a chisel point that presses against the other flat on the opposite side of the nut. And as you tighten this, it puts a crack in the side of the nut, and we use the next size up, or a, I won't talk brands, but one of these wrenches with this style open end, and it fits perfectly on there when the nut is cracked to remove it. So that's a little tip, save yourself some money. Don't destroy your valves trying to get the nuts off. These coils should lift right off. You may have to give them a little twist to get them off, but they should lift off. This is an excellent sign. C valves, very common to find them swollen. This portion, the stem is bulged, which comes from striking an object too hard, too fast. This one lifted right off, that's a good sign. Again, this is going to be a rebuilt unit. We don't reuse coils. All our rebuilds get new coils, new valves, new motors. In this case, the B valve has a little resistance. It may have something to do with this severe corrosion around the base of it. It's possible that once I remove this, I'm going to find that the what's the hex portion on this valve is actually round with two flats on this valve, which is an earlier design, and then they would put a steel ring over it for whatever reason, and that steel ring tends to rust in place. So we'll see what's going to happen here. We'll just give it a little persuasion. It's moving. It should come off. All right. Just give it a little twist. There we go. Okay. And it's actually a hex, but it's corroded pretty good. Again, we don't reuse the coils. Let's put it to the side. Now we'll bring our drain pan back, clean this area down because we don't want any debris that's laying on top of here to fall down in the cavities when we remove these valves. Drain pan. I'm actually going to dump some of the oil out of this into our pail. Okay. Again, tilt our pump. We got some more debris and oil that's settled down in here now with that stuff removed. We're going to dump that out. Brake cleaner and whatnot in there. We still have our A valve in the back of the sump base, which we'll get to later. I don't know if you can make it out. Right here is the cast date. Front of the pump, about 11 o'clock, looking at it, you'll see it says 84. The other thing that I've noticed with the older units is the lift ram. Chrome plating seems to be better quality than all the newer stuff. And all I can figure is that environmental regulations make chrome plating a very frowned upon process, which is why you'll see quite a bit now advertisements stating triple chrome plated, because years ago you could just get away with chrome plating. And nowadays, I guess the process, they don't give you as much chrome. I don't know. That's my thought. Okay, we got some more delamination here of the aluminum on the top of the valve block. Not sure what happened. These hexes on these valves are chewed up pretty good. Not really sure why. Hold it up so you can get a look at it. You can see there's some chew marks on here and here on this one. My best guess would be somebody didn't have a socket large enough and they used a pipe wrench to try to remove these. We do have a socket large enough. We'll see. Now they damaged the hex, of course, on this one more so than the B valve, more so than the C valve. What I'll do is I'll try tapping this on there a little better. Alright. Try with our 1/2 inch ratchet. See if I can remove this, and again, I don't like to beat on things with my hands, so I'm going to use the mallet. Wow, that's ridiculously loose. Again, a couple of turns on it, a little brake cleaner around the base there to help release the O-ring. There's our C cartridge valve. You can tell that this is probably original, 1984. And the reason I say that is because there's no screens on it. All the newer valves have filter screens to stop large debris from getting into the valve, causing problems. So again, we don't reuse valves. I actually have a friend that I give all my still usable parts to. Does quite a few rebuilds. So let's put that aside for him. Here's a piece of aluminum that was delaminating. Surprisingly, the actual surface machined into the valve block is in good shape, where the O-ring makes the seal around the base of the valve when you thread it in, which is a good thing. Let's see if I can get the socket to go on here. I'm actually going to remove the pilot check piston nut, which is this 13/16 nut here. I'm going to remove that first because I need to file this down, grind it down a little bit, and the nut's kind of in the way. You can see that somebody was on here too. There's chew marks, possibly when they used a pipe wrench. There's really no reason for the average guy to remove this unless you're doing a rebuild. And as I was saying, you can see that the surface where the O-ring makes a seal around the C valve cavity is nice and clean, even though the block is delaminated, as you can see here. starting to fall apart, and around here the aluminum is actually peeling away in layers. So we're going to remove this one and hope that it cooperates, because that could be a real bear to get out if it doesn't. So one of the tricks we use for that, getting it out in general, is we use a 6-point wrench or a 6-point socket. I prefer the 6-point wrench because the 6-point wrench has a heavier wall thickness than a 12-point, plus the flats are larger, so you're less likely to strip the nut. And the nut is aluminum, so here's our 6-point, 13/16